Programming is an aspect of the computing curriculum which is fundamental to understanding the basics of computer science. Creating a program involves putting together algorithms and code in order to create a set of instructions which can be followed by a computer. Due to the recent national curriculum changes, children are now expected to understand more about algorithms and programming from a younger age. Having compared both curriculums, I found the new curriculum to expect more detailed understanding of the processes and terminology involved in creating a program. A child's first experience of programming is likely to be through the exploration of electronic toys. An example of a readily available electronic toy is a remote control car. In my most recent placement, I observed children using remote control cars in free play. I found it interesting that only a handful of the children were able to control the cars with some accuracy. Siraj Blatchford and Whitebread suggested that children's coordination, fine motor skills and sense of direction and distances can be developed through the use of a remote control car. I think that introducing a set route, obstacle course or race when using remote control cars will enable the children to use the cars with more precision and therefore develop their skills further. A Bee-Bot is a type of floor robot which is very simple to use. This video shows children using a Bee-Bot on a number line to carry out a straightforward counting activity. Here you can see that the Bee-Bot travels a set distance for each step of the program and that the sections of the number line are measured to equal that distance. Other mats are available for Bee-Bots which allow children to formulate a variety of routes for Bee-Bot to follow. However, Williams and Easingwood suggest that more learning may occur if the children create their own courses. Without the squared mats, children will need to estimate the amount of time the Bee-Bot will need to move forward. This image shows a child using a Bee-Bot to pull a Lego trailer up a slope. This activity can develop an early understanding of forces. Price explained how a child observed a Bee-Bot moving slower up the slope when more weight was added to the trailer, which demonstrates a basic understanding of a cause and effect relationship. Programmable toys such as Bee-Bots are also known as control technology. Williams and Easingwood suggest that using control technology will develop investigative and problem-solving skills and attitudes applicable to scientific learning. I agree that these areas can be developed through explorative play with control technology. I believe that using Bee-Bots or similar control technology will encourage children to work collaboratively and cooperatively through pair programming. According to Williams and Easingwood, children will be able to practice speaking and listening skills when suggesting what the next move for the Bee-Bot would be. Extreme programming states that when children work in pairs, the program that is written will be much higher in quality. Scratch is a computer-based program which enables children to program a variety of objects. It follows similar instructions to those used in Logo and is therefore very simple to use. Scratch has recently brought out a program called Scratch Junior, which simplifies the programming operations further to cater for younger children. Berry outlines a range of ways in which Scratch can be used to incorporate other areas of the curriculum. A straightforward mathematical use for Scratch may be to draw shapes. This is a purposeful activity which will enable children to get to grips with using Scratch while learning about angles and lengths in relation to geometry. As stated in the Children's Technology Review, Scratch Junior can be used to create interactive stories. I think that the program will help children to sequence movement and use speech bubbles effectively. This may be a more accessible way of composing a story for children who struggle with writing. Solving a problem within a computer program is known as debugging. Due to the constructionist way in which programming is taught, it is likely that children will be able to detect where there is a fault within a program. Papert and Harrell concluded that constructionism is the notion that learning can occur through making. I think that the teaching of programming is very much a constructionist process. Children are able to learn through trial and error and therefore debug their own or others' programming errors. O'Donoghue developed a lesson idea which I believe will teach children what debugging is and also how to solve errors within code. He suggested starting with a code which definitely works and then adding errors to a partner's code. The children would then swap back and attempt to debug their original code. Programming is a very interactive area of the computing curriculum. It can teach children the basics of computer science through exploration and enjoyable tasks. Programming can also be used to enhance the learning of other areas of the curriculum. Jonason et al. Suggest that learning can become more accessible when the children are constructively involved in making something happen.